Hey everybody, I wanted to go over a Hess's law problem so that you see how we can manipulate these things. Okay, I kind of like Hess's law. It's for me, it's fun. So we're going to look at question 5.65 here. So I've cut and pasted it already over in my notebook here. And so the idea of Hess's law is that what we can do is we can take any combination of these reactions and we can switch and multiply the reactions so that when we take the reactions and add them up, that those reactions will add up to this overall reaction. Okay? And so these reactions somehow are going to add up to this reaction. Okay? Now, the way that I want to do this is by examining the reaction here to see what it has in common with this here. Okay? And so this first reaction, I underlined it, okay, so that you could see, but that first reaction here, let's see, I can take, and if we look, we have 2HF. Well, there's no HF anywhere else in any of the other reactions, and there's HF here. But there's a little bit of a difference, okay? The little bit of a difference is that in this reaction we have 2HF, and in this reaction we have 4HF. So how are we going to get HF here to look like HF here? Well, what we're going to end up doing is taking this whole reaction and multiplying it by 2. And by doing that, that makes the delta H multiplied by 2. Okay? So now let's see, we have a couple other things here. So now, in this second reaction, we have CF4. Well, here's CF4, but notice again the difference. The difference is that there's only one CF4, here there are 2. So somehow we have to get this to look like that, what we highlighted in green. Well, to do that, we're going to multiply that reaction by 2. Okay, so now that coefficient is going to end up being 2, and it matches what we have down here. Now for this third reaction, this is where it gets kind of interesting, is here we have C2H4, but in this reaction we have C2H4 down there. Okay, notice that this is a product and this is a reactant. So in order to get this reaction, or to get this to look like this, we have to take and we have to flip the reactants with the products. So we're going to flip that. Okay, we're going to turn the reaction around. Okay, and so now we have C2H4 on the reactant side here, because we flipped this over here, and we have it here. Okay, so now in order to do this, in order to find out what the delta H is, the delta H is equal to whatever we've done the manipulation. So we're going to do, okay, we're going to do negative 537 times 2 plus, we add them together, negative 680 times 2 plus, and then when we flip the reaction here, when we flip it, that makes this sign the opposite, so now it's going to be negative, so we're going to add a negative 52.3 kilojoules, and that is going to equal negative 2486.3 kilojoules. Now, I'm already predicting that there's people out there that are saying, well, what about this thing right here? What about F2? Okay, you haven't done anything with that, and that's bad news. Well, let's do something interesting with Hess's law. The whole point of Hess's law is that we're going to manipulate these given reactions to try to make them look like this target reaction. So what did we do to this first one? we multiplied it by 2. So let's take and let's multiply that first reaction by 2. So it's 2H2. I'm going to leave states off because it just takes up a lot of space. Okay, it reacts to form, and now we have 4HF. Okay, so now what did we do to the second reaction? We multiplied that by 2. So that's 2C plus 4F2 reacts to form 2CF4. Okay, now the last one we flipped. So that's going to be C2H4 reacts to form 2C plus 2H2. Okay, so now what I'm going to do is I'm going to add these reactions up. That's why I line up the arrows. I kind of try to always keep my arrows lined up through my whole thing. It's kind of just how weird I am. Okay, but if we're going to add this up, okay, let's do that. So we're going to take all the reactants, 2H2 plus 2F2, let's see, plus 2C plus 4F2 plus C2H4 reacts to form 4HF plus, I'm going to have to make this bigger, plus 2CF4 plus 2C plus 2H2. So there's a lot of craziness going on there. Okay, so now, let's see. We're going to combine things that are similar, and we're going to cancel out things that are on. We're going to cancel things that are on the same side, on the opposite sides of the equation, and we're going to combine things that are on the same side of the equation. So here we have an F2, and here we have an F2. So there's 2 and 4, so that's 6F2. So those are going to combine. And let's see, here we have 2H2, which is going to cancel out those 2H2. And now we have, let's see, 2C and 2C. And so now the overall reaction that we've just made, let's see, 2F and 4F2, so that's 6F2 plus C2H4 reacts to form 4HF plus 2CF4. Now, let's take a look. I'm going to take this and I'm going to move this guy up. And is that the same reaction as here? C2H4 plus 6F2 reacts to form 2CF4 plus 4HF. Sure. Okay, so if we can just use the one thing that is the same, the one compound that is the same, and manipulate it, we can trust that it's going to add up to the overall reaction that we want. Okay, so there's a Hess's law problem. Hope that clears it up, and have a great night.